In this video, we're going to be talking about heat and thermal energy. There is a definite difference between temperature, heat, and thermal energy. But a lot of people like to use them interchangeably when they are very closely related, but they're not actually the same thing. So temperature, we said, was the measure of the average kinetic energy of all the particles inside of an object. What heat is actually the transfer of energy between objects that are at different temperatures. So you have one object that is a higher temperature and one that is a lower temperature. The heat is going to be transferred from one to another, and that's the energy is going to be transferred from one to another, and that's what's defined as heat. It's kind of like it's giving off heat. That's what we feel when that energy is being transferred, is we're feeling that, and we call that heat. So one rule of thumb is that anytime that the energy is transferred, the heat is going to go from the object with the higher temperature to the object with the lower temperature. Remember, we've talked about how in physics and in nature, everything wants to balance out. It wants to be in equilibrium. So the ones with the higher temperature has a ton of energy and they're moving around really fast. So they naturally want to chill out a little bit and want to make the other particles speed up so that they're all balanced out at the same time. The definition of thermal energy is the total energy of the particles that make up a substance. So now we're looking at all of the energy of the particles. It's not the average energy like temperature was. Now we're looking at the total energy. So this is going to depend partially on the temperature, but it's also going to depend on how much of the substance that you have. The higher the temperature that we have, the more moving particles we have, that means we're going to have a higher thermal energy. So the higher the temperature means it's going to have more kinetic energy, so it contributes. And also, if you have more particles that are moving, that means you're going to have more total energy because there's more of them moving. So that's all going to contribute to that thermal energy. We have a chart here to compare the three, so you can see them side by side because they are very easy to get mixed up. Temperature is the measure of the average kinetic energy. Thermal is the total energy of the particles. Heat is the transfer of that energy between objects at different temperatures. Temperature we measure in Fahrenheit, Celsius, and Kelvin. Thermal energy is an energy, so we express it in joules. And then heat is also an energy, so we express it in joules, but we also can express it in calories. And then temperature does not depend on the mass of the substance. Remember, it's just the average kinetic energy, while thermal energy does depend on it. And the heat is going to also vary with the mass, but also brings in something called specific heat capacity, and it has to do with temperature of the substance as well. So we will talk a little more in detail about some of the words that are on here coming up later in the chapter. Another thing I want to touch on is thermal equilibrium. So like I said, everything in nature wants to be balanced out. It wants to be equal at equilibrium. So anytime that two objects are not the same temperature, that the energy is going to be passed from the one of the higher temperature to the one of the lower. And that's called thermal equilibrium. So once they have balanced out, once their temperatures are balanced out, that's when they're going to hit that equilibrium point. It's not all about the thermal energy because that's the total energy. We're kind of looking at the average. So everything wants to average out at the same point. So we have our thermal equilibrium is that point where that happens. So I want you to write for extra credit on this. Next to thermal equilibrium, right? Everything wants to average out. So everything wants to average out. Everything wants to be the same. So if you write that, I will give you extra credit for this note set. And the last thing I wanted to talk about here is something called thermal expansion. So we have talked about with our gases and our gas laws that hotter gases tend to have a bigger volume. Like we had a basketball outside in the winter, when it gets colder, the volume shrinks, so the basketball deflates, where if it gets warmer, it's going to cause the gas to expand and the volume is going to get bigger. So thermal expansion has to do with that. So if you have an increase in temperature, you now have more energy and those particles are moving faster and they're pushing that volume out. So as any substance gets hotter, the particles are going to move faster and they're going to spread out. If you've ever noticed summer compared to winter, girls, especially if you wear rings, guys, if you wear any rings, that in the wintertime your rings are more likely to fall off because your fingers are a little bit smaller because it's cold out. But in the summertime when it's warm, your hands tend to, people think of them as swelling because the particles are just a little bit more spread out than before. So the amount that the object expands is going to depend on the substance. Gases are going to expand more than a liquid, liquids expand more than a solid, but either way you're going to have some kind of expansion due to that higher temperature. And then one thing more is that this is how thermometers and thermostats work. A thermometer that is not digital, the ones with the red liquid inside of them, as the temperature heats up of whatever you're measuring, it causes that liquid to expand, and it expands and it keeps moving up and up and up because the temperature is getting higher. As it cools off, it starts to contract more, so that line's going to come down. There's a system within your thermostats where it's kind of like a thermometer, where as it heats up, it causes an expansion of some metallic strips within your thermostat, and it hits certain triggers, and it triggers your air and your heat to turn on and off. So we use thermal expansion and to our advantage in lots of different ways.